Okay, so the question today is product of array accept itself. So we have an array here, and for every value, we want to find the product of every other number. So, for example, if we look into this question here, for 1, the return value will be 24 because 2 times 3 times 4. For 12, also for 2, the value will be 12 because 1 times 3 times 4 and so on. Given this example, we can have a discussion that why not we create a variable which is product of all the values, and while calculating the result for every element, we can just divide that element from the product of all the elements and we'll get the product of rest of the element, which is true. But there is a few issues with that. One, uh, we need to take into account that there can be zeros present. So if zero is there in any place, that means the product will get nullified and we won't be able to get the answer that we are looking for the index which has 0 as actual value. Another thing, it's possible that the total product of all the value can exceed the 32-bit integer, so we don't want to do that either. So and we also want to do it in somewhat linear time. So let's just take an example of this. So what I was thinking is, instead of um, doing anything else, what if we just keep track of the left and the right product for every element? So let's say initially we create like two variables like this, two array like this, right? And let's just say this is LHS left hand side product and this is RHS right hand side products. So for 1, since there is nothing at the left, we'll just keep it as 1. We don't want to keep it as 0 because eventually we want to use this value to find the product of left and right. Okay, so for 2, it will be the current left hand side times the left hand side value, the current left hand side product value times the left hand side value, so it will be 1 times 1. For 3, it will be 2 times 1, and for 4, it will be 3 times 2, 6. Okay. Or this will be 2. Okay. Right. Okay. Now if we do the similar thing from the right hand side, this will be 1. This will be 4. This will be 12. And this will be 24. Right. Now for the result, what we can do is can use both of these array, and for every index we can just do the product of LHS that index times RHS that index. So 24 times 1 is 24, 12 times 1 is 12, 4 times 2 is 8, and 6 times 1 is 6. That will give us the answer. It's like it's pretty straightforward, I think. So like on a very high level, what we are doing is we're just keeping track of the left hand side product and right hand side product for every element, and we are doing this in linear time because we are going through this array twice to calculate this LHS RHS, which is a linear time, and then again one more time to get all the values. So let's just do that. Create a variable called LHS, and the value for this will be 0 times length of nums. We'll do another one, and then we'll name this RHS, and that's it. And then we'll have a result as well, and this result will be 0 times length of nums as well. These are all the variables we want. Now let's construct LHS. So for index in range length of nums, let's just give this 1, I think. So if we give it 1, the edge cases will be covered, so the top left side and top right side should be 1, so that case will be covered. Okay, so for index and range this, obviously for the first value the answer will be 1, so we don't need to do that. So we'll just start from index 1, and basically LHS of index will be equals to LHS of um, index minus 1 times nums of index here, and we do the same thing, but this time we go from right to left, so it's minus 1, so again we don't want to um, do this, so we don't want to track the last value because that's fine. We want to keep 1 for the last one, so it should be okay. Will be RHS of index plus 1 times nums of index, right? And if you print LHS and RHS, you should get the value that we are looking for. So 1 2 6 12 20, sorry, 1 2 6 24, okay, and then 6 6 3 1. That doesn't seem right. So for LHS it should be 1 2 6 and 24. That's correct. For RHS it should be 1 4. Okay, it should be 4. I think we need to start from here. No, so if we start from here, it doesn't make sense. We start from here. So RHS product will be the current index time RHS index plus 1, which is correct, right? Nums of index. Index. So I think it will be plus 1 because we're starting from there. Yeah, okay. But then one to length of nums. Oh, right. Okay, so the issue here was we were including the current number as well. So if you see here, let's say we are processing 2, we are actually including 2 in the product as well. We should not include 2. That's why this was the issue. Now what we'll do is for I in range, length of result of I is equals to LHS of I times RHS of I, and then we return result. That's not it. So it should be a linear time solution. Cool, let me know what you think. Thank you.